Okay, so I want to remind you guys real quick about something that we did last week. Let's look right here at number 13. Y'all remember when we factored this last week? We factored using three different forms, kind of. Kind of four. One, we started with greatest common factor, right? Greatest common factor is always going to be the first method that we talk about. We also talked about factoring trinomials. Now, in that specific method, trinomials can sometimes, a lot of times, factor into what? Are y'all with me? Two binomials, right? So we talked kind of about two different methods there, kind of. When your A value is not 1, we use that method called it's over here on the screen, y'all. Over under. Remember that? But then we also talked about one more method. So kind of 3, kind of 4. And that was if you ever have a binomial where your two terms are both perfect squares and the sign in between is a minus. We call that difference of squares. We said that's the one time that a binomial will factor into what? Two binomials. Those were the different methods of factoring that we talked about. But I want to do something real quickly to kind of get us ready for what we're doing today. See, if I were to take this factor, y'all see the factor? We did it. We did over under. It came up with 2x minus 3 times x minus 6. Got it? If I were to take this original factor, 2x squared minus 15x plus 18, and I go to y equals, and I go type it in, 2x squared minus 15x plus 18, and I were to graph it, a couple things that we've already discussed. One, this is definitely the graph of a quadratic. It's definitely open up. It's shifted to the right and down, right? We know all these things, but we also talked about the fact that these things cross the x-axis where? What is this value? 1.5. It looks like to me, doesn't it? It's right in between 1 and 2. And then, let's see, that's 1, 2, 3, 4, 5. It also crosses it at, so it crosses it at 1.5, and it crosses it at 6. So what do we call any equation that at the place where it crosses the x-axis? We call those starts with an S, ends in olutions.
Solutions.
We call them solutions. Very good. We call them solutions. If you guys think back about equations that y'all used to solve, linear ones, the solution that you would get, x equals whatever number, if I graph that linear equation, guess what it would do at the x-axis, at that spot? It would cross it right there. That's what you're doing when you find the solution. You're finding where it crosses the x-axis. Now, what was this again?
1.5.
And what was this one?
6.
Okay, remember that. Is there a connection between those solutions and my factors?
Yes.
Look, what were my factors again? What were my factors? What were my factors?
2x minus 3.
2x minus 3. And
X minus 6.
is there a connection between those factors and my solutions? What did we say the solutions were? 1.5. And do you see the connection? How could I turn 2x minus 3 into 1.5? How could I turn that 2x minus 3 into 1.5? If I took 2x minus 3 and set it equal to 0, what would happen? How would I solve that? How do you move that 3? So 2x equals positive 3, and then I would, and what is 3 divided by 2? There is a connection. I don't know if he's being sarcastic
I don't either.
or if he's
actually, like, for real, that's
okay. Yeah, I mean that's.
when I saw it, I was like, this ain't right. But no, whoa, that's-
And then if I took the x minus 6, of course, and I set it equal to 0 and solved, what would it give me? The same solutions that we got when we graphed this thing and looked to see where it did what? Cross the. Okay, here's the point. There absolutely is a connection between the solutions of a quadratic and the factors of that quadratic. The factors will give me the solutions if I do what with them? And solve. Right? If I set them equal to 0 and solve, then the factors will give me the what? The solutions. Does everybody see that? Okay, then that's what we're doing today. We are what we call solving by factoring. We're solving by factoring. Well, how will I solve by factoring? Well, I will factor it, and then I'll take the factors and I will how? Set them equal to 0, and then I'll solve. So that's what we're doing today. Hey, what is wrong with you?
Yeah, I know, he took the
crust
off the pasta.
He's like, when it hasn't been cooked, the crust is good. When it hasn't been cooked, the crust is not quite as good, but he's just a weirdo.
Yeah,
I don't like it.
Brody's just eating straight crust.
Hey, a little bit of cinnamon.
I like the crust.
I mean, let's be honest. He's a strange guy. I mean, just enjoy the Pop-Tart or don't. Don't waste it.
I do enjoy the Pop-Tart.
You waste it. Look how much you're wasting.
No, Brody's eating it.
Okay. So today, like I said, we're solving by factoring. So are we really doing anything today that's going to be hard?
No. Yes.
If you understood factoring, it's not hard at all. It's not hard at all. At all hard. It's not. Okay? There are 3 different methods, really. There's GCF, right? Greatest common factor. There's factoring a trinomial into 2 binomials. Now, sometimes we have to use over under. And then there's factoring difference of squares into 2 binomials. But once I get those factors, I solve by factoring by taking those factors, setting them equal to 0 and solving. Manny, I couldn't help but think I needed to ask you how you danced this weekend. Did you do good?
Harder than the Mr. Soccer game.
Huh? Was everybody pleased with your performance?
I didn't realize Peke was good at either.
Well, congratulations, man.
He danced too hard.
I'm sure you made someone's day.
What
Yeah.
are y'all dancing for? What's that?
Birthday party.
Why can't you just say birthday party?
Because it's not a birthday party, it's like a party.
It's like a Sweet 16 but 50, and you have to.
5 times like 20. Like
Yeah.
it's like
Big time.
Big
time. All right, so that's what we're doing today, okay? Now, in my process, if you go to the back side of this worksheet, you'll see that sometimes before I start factoring, I got to move all my terms on one side. You can't factor until everything's on one side, okay? That's easy. And then, of course, we're going to factor using one of those methods that we talked about last week, all right? Nothing new. But then we set those factors equal to 0 and we solve. Now that last step where it's write your answer solution set, you don't have to mark through that like I just did. I erased it. But we're not going to really worry about that. We're just going to solve, okay? Y'all ready? So look at number 1. And I want you guys to kind of go through your process of thinking. What needs to be the first thing you see? Is everything on one side? Yes. What's the first thing we always ask when we're factoring? Yes. Is there a greatest common factor here, y'all? Are you sure?
Oh,
But taking a 1 out doesn't really help me. So there's no GCF? You sure?
Yeah, unless it's just a trick question.
Yeah, maybe it's not.
There is one.
What?
What do both these terms have in
Oh,
common?
they get squared.
They both have an
Oh, yeah.
x.
Look, it's like 2 o'clock.
They both have at least an x. Don't forget about x. Yeah, there's no number, well, 1, but that doesn't help me. But there's a variable in both terms up to an x. We can pull it out. That's an important factor. If you have a variable as part of your GCF, it's important. Now, I pull the x out of x squared. What does it leave me with? What's x squared divided by x? X. What about positive 9x divided by x?
9 positive.
Positive 9. So there's my factors that's left over. Can I do anything else with this?
No.
No. Then what do we do next? We factored it. How do we solve by factoring? We set
each factor equal to 0.
and what's our first factor here? X. Set x equal to 0. Now, there's not much solving to that. And then set x plus 9 equal to 0. I need to solve that one. What do I do?
Minus 9.
So 0 minus 9, negative 9. So guys, listen. And I promise you, if you go to your graphic calculator and you go to y equals, here's what I guarantee you'll see. 1, it's a quadratic. It's a parabola, I promise you. It's x squared, your biggest term. It's a parabola. It's open up because your a value is positive. And I guarantee you it's crossing the x-axis at 0 and at positive 9.
Negative 9.
At negative 9. I promise. Okay? Because that's what you're doing when you solve by factoring. You're finding where your quadratic crosses the x-axis. Okay? You with me? This is hard?
No.
Not if you know how to factor. Let's keep cruising. Number 3. Is everything on one side?
Yes.
Alright. Is there a GCF?
No.
No.
Nope. Well, it's a binomial. There's only one other type of binomial we've even talked about factoring. And it's called difference. Is this difference?
Yes.
Of perfect squares. Are these perfect squares? Then this is one of those times, because it's difference of squares, where it will factor into 2 whats? What will multiply by itself to get x squared? X. What will multiply by itself to get 4? 2. And y'all remember what the rule was with this? Plus, minus. For that middle term to have canceled, those had to be positive and negative, or negative and positive. It doesn't matter your order. But what do we do now that we have our factors?
Set to 0.
We set them equal to 0, and now what we're doing is we're solving by factoring. Yes, sir.
If it's like if you turn into difference of squares, do you really have to set it to 0, or is it like super easy to go ahead and tell it that?
It's easy. Yep, it's super easy. Alright, it's super easy. I'm going to keep doing it because I'm thorough, but it's super easy. X is going to equal what 2 values? Negative 2, and x is going to equal positive 2. Solve by factoring. You factor it, but the connection between the factors and the solutions are you take your factors, set them equal to 0, and solve. Look at number 5. We don't have to go super slow. We can go fast if y'all understand this well. Is everything on one side?
Yes.
Alright. Is there a greatest common factor?
Yes.
What?
X.
Can I pull x out of 21?
No, I lied.
It's okay. If I can't pull out of everything, I can't pull it out of anything. Right?
I don't know.
Yeah, no GCF. So this is a trinomial. And we've talked about factoring trinomials into 2 whats? So that's my thought process. I'm going to try to factor this into 2 binomials. I look at my a value, it's 1. So I know this is the easy factor. Easy factor. What will multiply by itself to get x squared?
X.
What multiplies to get a positive, you guys? Either two negatives or two positives. I look in the center and it tells me it's got to be two
Negative.
So with those signs being the same, that tells me I'm looking to see the two numbers that will multiply to get 21, but combine to get 10.
7 and 3.
It's got to be 7 and 3. Doesn't matter where we put them. No, because they're both just x minus, aren't they? If they're both x minus, I can put either one either place. So it doesn't matter. So what do we do with those factors, y'all?
Set them to 0.
Set them equal to 0, and we solve. So that's a positive 7. Set that x minus 3 equal to 0, and we solve. So that's a positive 3. I promise you this. This is a quadratic. It's open up. It's crossing the x-axis at positive 7 and at positive 3. I guarantee it. Go look at it if you want. I guarantee it's doing that.
It doesn't show
You type something in wrong.
You type something wrong.
X squared minus.
You have to zoom out. You have to zoom in, but you can't actually see.
What happened?
I don't know.
We just broke it.
Seriously?
Bro, what happened?
Oh, it finally appeared. It was like 5 years.
Did you? Sometimes if you push enter twice, it'll pause it. It'll pause the graphic.
Oh, that might have been what I did.
Yeah. All right. Number 7. Everything on one side.
Yeah.
All right, that's done. Trinomials are GCF.
No.
Yes.
No, but we're on 13.
Yeah, 13's prime. I know you see the 3's and you think, I bet I can pull 3 out, but 13's prime. So no GCF. So we immediately think, all right, it's a trinomial. I'm going to try to factor it into 2 binomials. But we see an A value of, so we're going to use what method, y'all? The over-under. If it works, over-under is the same thing as going up and going down. It's whatever, Manny. Be good. Just keep. That's fine. That's fine. When you get nervous, you pull the things off the tab, those things off your pencil. You just broke your pencil. Now you can't clip that to your pocket if you want to carry it around.
Why am I going to carry it?
Because that's what cool people do.
Okay. That's a costless thing, don't worry.
Yeah. Alright, so when we go over under, remember, we're basically moving that to make life easier to begin with. So when we move that 3 away, we're left with x squared minus 13x. But what will 3 times negative 30 give me? And now we're just going to easy style factor, right? Where we can say, hey, what multiplies to get x squared? Well, it multiplies to get a negative. Plus and a minus, so they're fighting each other. So we're looking for the two numbers, because those signs are opposite, the two numbers that will multiply to get 90 but have a difference of 13. 5 and 18. Now listen, don't forget, finding these is not rocket science. You just start dividing. 90 divided by 2. 45 and 2 have a difference of 43. 90 divided by 3. You just start dividing. No, that's 27. 90 divided by 4. That doesn't work. 90 divided by 5. And there it is. 18 and 5 have a difference of 13. So don't make finding these more complicated than you need to. Just start dividing. 18 and 5 have to be my factors. What are my factors? 18 and 5. Now look back here at this problem. Minus dominated the middle. So you put minus with the big one. Which one's big, 18 or 5?
18.
So it's minus 18, it's plus 5. Now, are those the factors that I'm setting equal to 0 and solving?
No, we didn't do it under.
Yep, we did the over or the up, but we haven't done the under or the down. Or are you going to go with up and under? Up and under sounds like a soccer move. So let's go with that. Up and
Over and below.
No, that doesn't sound like a soccer move. So we're going to go under now. So under 3 on both of these. If it will reduce, we reduce it. Now listen, this was asked in first period. I thought it was a great question. I had never really even thought about this question. Am I factoring these? Is that my end goal? Is my end goal factoring? No. What's my end goal here?
Solving.
Solve by factoring. Here's the point. Here's the point. Eventually, what are we going to do with these factors anyways? Set them equal to 0 and solve. Right? Here's the point. The actual way we would write this first one as a factor would be what? Right? Y'all all understand that?
Yep.
If I were asking you just to factor it, I would expect you to write 3x minus 5. Do you understand that? Let me say it one more time. If I was expecting you to just factor, I would want you to write this factor as x minus, or 3x minus, or plus 5. Do you hear me? But I'm not asking you just to factor. I'm asking you to solve by factoring. And what are you going to do with these factors anyways? So save a step and just go ahead and take x plus 5/3 and set it equal to 0. And then, of course, what's the other one? What is 18 divided by 3? So x minus 6 and set it equal to 0. Since you're not needing to just factor, you're solving by factor, save yourself a step. What would I do with this problem? Say subtract 5/3.
Subtract 5/3.
Very good. You subtract 5/3, so it's negative 5/3. What would you do with the other one? Go. Yes. What would we do with the other one? Then I'll go back to that question.
X for 6.
Add 6, so x equals 6. Now, Trace asked a good question. If I told you guys that the x-intercept is at negative 5/3, do y'all picture that? But what is negative divided by 5 divided by 3? It's negative 1.6 repeating. If I told you that it goes through your x-axis at negative 1.6, does that make more sense? Then absolutely, if you want to write it as a decimal, do so. Okay? Absolutely write it as a decimal if that helps you picture it. Brody, did you have a question? You raised your hand.
I did.
I thought so.
Oh,
You did it?
I don't remember.
Okay.
I think you're just stretching.
Okay. It was one hand. Not many people do a one-hand stretch. I guess.
I could get like, I don't remember how to.
So you didn't have a question for me at any point?
I don't think Brady ever has questions.
Okay. Everybody good? Let's keep on cruising then. Here's the first one in the back, where we have to start doing what? Moving stuff to one side. Guys, always move it to the side where your x squared term can be positive. Is my x squared term positive on the left? Then move everything to it. So how do I move that 5x?
Mine
We subtract it. Alright guys, how do I factor this thing? Does it have a GCF?
Oh,
Yes.
X, yeah.
It has x. Don't let that one trick you guys. It has just x. Can't pull a 2 out, but you can pull an x out of both terms. So if I pull x out of 2x squared, what's it leave me with? 2x. Just 2x. Because one of those canceled, right? And then what's negative 5x divided by 2? Or by x, I'm sorry. Negative 5. Alright, so guys, what do we do with those factors? So I'm going to set x equal to 0. That was one of my factors. And I'm going to set 2x minus 5 equal to 0, because that was one of my factors. I don't have to solve the x equals 0. It's already done. It crosses my x-axis at 0. Guarantee it. Right through the origin it goes through. But this one, you're going to add 5. And then you're going to divide by 2. So kind of like Trey said. Would 5 over 2 x-intercept make sense to you guys? But what does make sense? 2.5. I can picture 2.5. I can't picture 5 over 2 as well. Some of us can, but some of us can't. Decimals though, you can picture 2.5. So change it if you like. Or don't. Either way, it's right. What else what you gonna do? You gonna change it? You're so quiet. You don't say much, do you? Are you ever in an environment where you talk a lot?
No.
No? Always quiet? Alright. There's plenty of people who talk enough for all of us.
Yeah, I think he makes up for it. It's okay.
I was looking at Katie, y'all, in case y'all were wondering. Okay, here we go.
Shut up. Back on your phone, that's that way.
Man, don't get on your phone.
Get back on the Desmos.
Yeah, it's Desmos.
Get back on the Desmos.
is so addictive.
Yeah, I'm sure that's what it is. Okay. Alright, let's move along. No Desmos. I know it's so much fun. But let's use our calculator that's on your left hand there. Yeah, there it is. No, it's not.
Then you can't fix it.
In fact, the numbers on it are so small, it's hard to push right. Especially you got big old fat
I got
fingers.
small little fingers.
Yeah, okay. Alright, what's the first step, y'all?
Subtracting
Get everything on
the left.
one side. So I'm going to subtract that x squared from what?
The other left
The
side.
2x squared. Which they're like terms, right?
Wouldn't that just make it two?
No, because 2 minus 1 is.
Would it be like,
No, that's it.
wouldn't the x squared cancel out though?
Yeah.
No, it's like,
What's
so when
2
you're,
minus 2?
when you're combining like terms, your variable stays the same. Okay? So 2 minus 1 would just make it 1 x squared.
Why is it 1 though?
Because 2 minus 1,
Because the X is.
that's understood to be a 1.
Oh.
So
You're right. Hey,
Now I'm going to add 1, of course, to the negative 50, because those are also like terms. So here's what I'm left with. 2x squared minus 1x squared is x squared. Negative 50 plus 1 is? Alright. So let's try to factor. Is there a GCF? No, look, 49 does not have an x. No GCF. It's a binomial. I've only talked about factoring one other type of binomial. Difference.
Of square.
Is it?
Yes.
It's definitely a minus sign, and those are definitely both perfect squares. So we're going to factor into 2 binomials. What multiplies by itself to get x squared? X. What multiplies by itself to get 49? 7. And what's the rule, y'all? Plus and minus. Those are my 2 factors. So, if I were to take those, set them equal to 0, and solve, on that first one, I'm going to subtract 7. So x will equal negative 7. And on that second one, I'm going to add 7. So x equals positive 7. What do y'all think? Not bad? We good? Let's keep moving. 13.
Well, I did not know that.
You just taught me something cool.
Sweet.
And he on my phone.
Alright, so let's get everything on one side. Look, the x squared is positive over here on the left. Leave it. So what's the only thing we need to move? We need to move the 80, and it will be by minusing it. It will be minus 80. So we have x squared plus 2x minus 80 equals 0. Any GCF here? Will x come out of 80?
No, I keep saying I lied again.
It's alright. Just remember, you can't pull it out of everything. You can't pull it out of anything. And 80 don't have it. Alright, so it's a trinomial, no GCF. And my a value is 1. This is the easy factor. The easy factor. What multiplies to get x squared? What multiplies to get a negative? A positive and a negative. Remember, they offset each other. So we're looking for the numbers that multiply to get 80 have a difference of 2.
8 and 10.
8 and 10. Again, remember guys, you got a couple of options. You have 80 on that little sheet I gave you. Also, you can go to your calculator and just start dividing. 80 divided by 2. No, that's 2 and 40. 80 divided by 3 doesn't work. 80 divided by 4, that's 4 and 20. 80 divided by 5. No, that's, what would that be? Not 13. 13. Is that right? Until you get to 80 divided by 8, 8 and 10. There it is. Now, what sign dominated the middle? Positive. So it has to go with my bigger factor. Which one's bigger, 8 or 10? So it's got to be plus 10. It's got to be minus 8. Y'all with me? Now, we're done factoring. What do we do with them? Set them equal to 0 and solve. This one we subtract 10, so negative 10. This one we add 8, so positive 8. So positive 8 and negative 10, I guarantee you, are the two places where this graph would do what? Exactly. Please remember, that's what we're doing. That's what we're finding. The solutions is where it crosses the x-axis. All right, number 15. Got a lot of stuff to move. But here's what's going to help me decide where I'm moving it. Here's 2x squared. Here's 1x squared. Which one's bigger? So move the small one towards it by subtracting. And then where am I going to add this x? To that negative 9x, right? Like terms. So here's what we're left with. What's 2x squared minus 1x squared?
X squared.
X squared. What's negative 9 plus 1 or 1 minus 9? Negative 8x. And then minus 65 equals 0. Alright? Now, next. Is there a GCF?
No.
Nope, it's a trinomial, and my A value is easy factor. What multiplies by itself to get x squared? X times x. What multiplies to get a negative? Positive and a negative. So we're looking for the two numbers that accomplish what? Multiply to get 65, but have a difference of 8. Multiply to get 65, difference of 8. So let's go see. I'm going to go use my Desmos since it's so much fun. So multiply to get 65 has a difference of 8. So 65, dang it. 65 divided by 5.
Yeah.
13. There it is. Wouldn't have taken you long. You would have done 65 divided by 1 or 2, didn't work. 65 by 3 doesn't work. 65 divided by 4 doesn't work. 65 divided by 5. First one that worked is the answer. 5 and 13. Difference of 8. So my last thing is this. What sign dominates the middle? Negative has to go with the bigger factor. Which one's bigger, 13 or 5? So minus 13 plus 5. So what do we do with those factors? So set it equal to 0. That one I'm going to subtract 5. Then x minus 13, set it equal to 0, add 13. So positive 13 and negative 5. I guarantee it, if you graphed it, you would see it crossing the x-axis at negative 5. You wouldn't see it cross at positive 13 because positive 13 is off the graph. Now you can zoom out, and that's where it'll be. All right, last one. Is this ready to factor? Say no.
No.
Because everything needs to be on, well, the 2x squared is positive on the left, so everything's moving towards it. We ain't going to move just that one. It's positive. Leave it where it's positive. So subtract the x, subtract the 21, and now we can think about factoring. Yes, go.
Why do you do that?
Because you don't want to factor with an x squared coefficient that's negative. You really don't.
It's like 10 times.
It's not 10 times, but it's more difficult. Just like with factoring trinomials, when you're trying to do the outside and inside and stuff, and you got one term that's negative and one term that's not negative, how do you know which one's negative, which one's positive? We got to try it. You got to put it. But if they're both positive, you don't have to try that. Does that make sense? So it just makes life easier to leave your x squared coefficient positive. Life is easier. Okay, so here we go. I know there's no GCF, right? But I look at this thing, and I'm ready to factor it, and I see an A value that's not 1. It's a 2. So we're going to do what again?
Multiply.
We're going to do over, under, up and under. Okay? For soccer players. So we're going to rewrite this as x squared minus x. And what is 2 times 21?
42.
42. So let's factor. Easy stop now. X times x gives me x squared. We're looking for the two numbers that multiply to get 42, have a difference of
-1.
1. What multiplies to get 42 has a difference of 1?
7 and 6.
It's got to be 7 and 6. It's got to be 7 and 6. Now look, what sign dominates the middle? So it has to go with your bigger one. Which one's bigger, 7 or 6? So -7, +6. Are those my factors?
No, I got to
We got to go under with that 2. Now listen, do you have to rewrite these? No, because we're solved by factoring. So we're going to just go ahead and take that x minus 7 over 2, unless you want to change it, and that x plus 3, what did I just do? X plus 3, I went ahead and simplified that one. And we'll set those equal to 0 and solve. So this one, I'm either going to write it as positive 7 over 2, or preferably, what is 7 divided by 2? 3.5. And then over here, we're going to subtract that 3, so x equals -3. So my two solutions, 3.5 and -3. I promise you, if you graphed it, you would see it crossing the x-axis right there to those values. Now, do you know what your homework is?
The evens.
I'm gonna guess the even.
You got it.
Really fun.
All of them. Yeah. There's only what, 9?
Only.
There's 9.
Dude, I forgot that time ago. I thought we were freaking.
So your evens, 2, 4, 6, 8, 10, 12, 14, 16, 8, 9 problems. You guys, easy peasy. What is that? Okay.